Okay, so let's just dive right in. Every so often in the world of AI, a new term just explodes onto the scene, promising a complete revolution. And today, we're looking at one of those, the Predictive Action Orchestrator, or PAO for short. It's been announced with some incredibly bold claims, but as always, we're here to separate the genuine breakthrough from the marketing hype. So what is this thing really?
And this is the kind of language that gets everyone's attention, right? A monumental leap, a paradigm shift. We're not just talking about a faster model here. The promise is a fundamental change in how AI thinks. The claim is that an AI can now have foresight. So our job in this explainer is to get to the bottom of that. Is it real?
So first, let's take these claims at face value. What's the grand vision they're selling here? What is this system, in theory, supposed to deliver that the AI we have today can't?
What you'll notice right away is that the focus here isn't just on planning a series of steps. It's all about prediction and consequence. The claim is the PAO can see the ripple effects of its actions. Think about the ethics of those ripples, and then pivot if the world suddenly changes. It's a huge shift from a reactive, do this, then that model, to a proactive, wait, what if I do this model?
So if you remember one thing, it's this. Forget just predicting the next word in a sentence. The core promise of PAO is an AI that can run these little mini simulations of the future in some abstract internal space, just to see how its decisions might play out. It's basically about looking before you leap, but for an artificial intelligence. All right, so that's the big promise. And it sounds incredible, doesn't it? But now it's time for the reality check. What is this orchestrator actually made of? Let's pop the hood and see if the engine is really brand new, or if it's just a clever assembly of parts we've actually seen before. And this gets to the absolute core of our investigation. Because when you break PAO down into its four main components, they start to look, well, really familiar. The perception layer, that's using stuff like CLIP to understand inputs. The impact analyzer, that's basically reward modeling, like we see in RLHF. The execution orchestrator is a tool use loop, super similar to React or LangGraph. And that simulation engine, well, it's described as using Monte Carlo tree search.
And for anyone who's not familiar, Monte Carlo tree search, or MCTS, is not some new invention. This is the powerhouse algorithm that helped DeepMind's AlphaGo beat the world's best Go players years ago. It's a proven, incredibly powerful technique for exploring possible futures in a complex system. Seeing it here is a major clue about what PAO is really doing.
So this leads us to our first really big conclusion. Based on its own description, the Predictive Action Orchestrator isn't some revolutionary new type of AI model. Instead, it seems to be a very sophisticated framework, a kind of meta-controller, that cleverly combines several powerful but existing AI techniques into one single workflow.
Now, this whole idea of predicting things in an abstract space, it's not happening in a vacuum. To really get the philosophy behind PAO, it is super helpful to look at a real, well-documented research direction from Meta AI, led by Yann LeCun, called JEPA. Let's see how they stack up.
Okay, the similarities are pretty striking. Both PAO and JEPA are built on this idea that predicting every single pixel or every single word is just inefficient and flawed. Instead, they both try to predict what's going to happen next in a compressed, abstract space. They both share this goal of giving AI a world model, an intuitive grasp of how things work. But the difference, and this is absolutely critical, is how they do it. PAO is described as a system that runs on top of an existing LLM to guide its actions. JEPA is a fundamental method for training a new model from the ground up. And I just love this analogy from the source material because it makes the distinction so clear. Think of it this way. JEPA is trying to build that deep, intuitive world model in the brain. PAO acts like the prefrontal cortex, the executive function that uses that model to decide what to do next. One is about foundational understanding, the other is about action and orchestration.
Okay, so we've deconstructed the architecture, and we've put it in context with the rest of the research field. But this brings us to the most important question of all. The claims are grand, but how could you actually prove them? How do you scientifically test for foresight in an AI?
I mean, this is the key question for any new framework, isn't it? It's one thing to say you've put MCTS and React together in a clever way. It's another thing entirely to prove that your combination produces a result that is measurably better, that it actually demonstrates the foresight it claims to have. So how would we even design a test for that?
Well, here's a brilliant and really concrete example of how you could. Imagine you give an AI a 5-step task, but you build in a hidden point of failure. A standard agent would just run the steps, hit step 3, fail, and then try to recover. The real test for PAO is whether its simulation engine can identify that potential failure right at the beginning, and then create a plan to deal with it before it even starts. That's a measurable test for being proactive.
And here's another great one, this one for ethical foresight. You give the AI a request that seems totally harmless on the surface, like, hey, find some addresses for a community mailing, but which would lead to a policy violation. A standard LLM might just follow the instructions and collect that private information, but a system with a true impact analyzer, like PAO claims to have, should simulate that action chain, see that it leads to a bad outcome, and refuse the task before it even takes the first step.
So after looking at the claims, the architecture, and how we might even test it, where do we land? Is the Predictive Action Orchestrator a true innovation, or is it a really, really clever synthesis of ideas we already had? Let's try to summarize the verdict.
The assessment is really a mixed bag. On one hand, the ideas behind PAO, especially its focus on non-generative latent space prediction, are absolutely aligned with where the cutting edge of AI research is going. That's a huge plus. But on the other hand, it seems to be a proprietary closed-source framework. There are no papers, no code, no benchmarks. And without that proof, those huge claims of a paradigm shift, they're just that, claims.
And this really is the bottom line. From a scientific perspective, the biggest risk for PAO is that without any real proof or open verification, it could be dismissed as just a very advanced form of prompt engineering. A clever script that makes an LLM act like it has foresight, rather than it being a fundamentally new capability. And that line can be very, very thin.
Which leaves us with one final thought. We've deconstructed the hype and the reality of this one specific framework, but the process is what really matters. The next time you see a big announcement for some paradigm-shifting AI, you're now equipped with the critical questions to ask. What are its components really? How does it compare to existing research? And most importantly, how would you actually test its claims? That's how we all navigate the future of AI.